All right, so on to pH regulation, if I can get my slide to advance. All right, so how do we handle pH? Well, we have our favorite equation, right? So we have carbon dioxide and water in the presence of carbonic anhydrase will form carbonic acid, which quickly dissociates into bicarbonate and hydrogen ions, right? We saw this in the hemoglobin system. We saw this is the way you exhale carbon dioxide and how we form hydrochloric acid by parietal cells in the stomach. Well, guess what? Your kidneys get to use this equation as well, which is really pretty, I don't know, I kind of think it's cool. And I think I mentioned this to you as well in another video, but this equation is also how we get ocean acidification and like coral bleaching. So basically, like all the carbon dioxide in the atmosphere, dissolves in water, and slowly over time, because there's no necessarily not there isn't any carbonic anhydrase, but you end up having lots of hydrogen ions, which then cause ocean acidification and even acid rain. Anyway, what I think is really kind of cool about it is that your different body parts will use the same thing, right, the same mechanism in so many different ways, either to buffer your blood or, exhale carbon dioxide or make stomach acid. I just think it's really neat. Anyway, you have two different ways to compensate for changes in pH. Remember, you're trying to keep your blood pH at a very strict range, right? 7.35 and 7.45, so in between those two. There's two different ways you can try to correct the problem, either via the respiratory system or the kidneys, okay? And why do you care? Well, if your blood becomes too acidic, it can cause problems with the central nervous system, resulting in a coma. That's clearly not a good thing. And if it becomes too basic, it can actually cause neurons to fire too much, which can cause spasms, convulsions, and death. Yet that's not so good either. So again, we need to make sure we keep the acid base in check at a nice balance. All right, so let's talk about the conditions. You have something called respiratory acidosis, and you also have metabolic acidosis. So what is respiratory acidosis? So that's an increase in carbon dioxide, okay, and a decrease in pH if there's no compensation, like you can't change it. So basically an increase in carbon dioxide, and what would that do? That would cause this equation to go toward the right and increase the amount of hydrogen ions, which would then decrease pH. Okay. What causes it? Usually you're not breathing properly. That's why it's respiratory acidosis. So that could be due to emphysema, pulmonary edema, so like water and fluid in the lungs, or airway obstruction. Okay. So your kidneys then try to compensate for that, because obviously you can't do it respiratorily. That's where the problem lies. So your kidneys then try to compensate for that. And they try to compensate by excreting more hydrogen ions and reabsorbing more of the bicarbonate ions. Okay, so does that make sense? So respiratory acidosis is due to increased carbon dioxide levels, okay, and therefore decrease in pH, as we see in this equation. And it's due to, for some reason, hypoventilation, not getting enough oxygen, essentially. And the body part that's going to try to compensate for that is going to be kidneys by excreting those hydrogen ions and reabsorbing bicarbonate ions. Now, metabolic acidosis is a little bit different. So again, we have the same kind of idea. We have an acidic condition, so we have a decrease in pH below that 7.35. However, it's due to too little bicarbonate ions. Okay, so we're losing these bicarbonate ions, and again, that's not helping us buffer any of the hydrogen ions. So when do we lose these bicarbonate ions? Well, if you have diarrhea, you tend to lose a lot in like loose stool. Renal dysfunction, like your kidneys are just filtering out way too much for some reason, or not being able to reabsorb it, or an accumulation of acid, as you might see in like extreme ketosis. So what's your body to do? Well, you're going to hyperventilate, meaning you're going to breathe more. You're going to increase your breathing rate, because the more you breathe, the more carbon dioxide you're going to give off, the more and water vapor, so the more hydrogen you're going to pull from your bloodstream, and therefore decreasing hydrogen ion levels is going to increase your pH, so it'll counteract the acidosis. So what about alkalosis? So now a high pH. So the last two were low pH, now high pH. So again, we can have respiratory alkalosis and then metabolic alkalosis. So respiratory alkalosis is due to too little carbon dioxide levels. Again, if we have too little carbon dioxide levels, we're going to be pulling hydrogen ions this way as we've lost them. And by doing that, we're going to increase our pH, so above that 7.45. And again, convulsions, spasms, death, not such a good idea. And common causes are things like hyperventilation. So you would hyperventilate, you're trying to breathe in and out too much because there's an oxygen deficiency like at high altitudes, or if you're anxious. You've probably seen people like hyperventilate because they freak out about something, they start breathing too quickly, and then they pass out, right? And so basically, other than in the case of anxiety where you might just pass out and have the medulla and pons take over breathing for you, if you cannot compensate for it that way, like if you're at high altitude, right, that's not going to help. Your kidneys are going to basically decrease the excretion of hydrogen ions. So by holding on to hydrogen ions, it's going to lower your pH. And they're going to decrease the reabsorption of bicarbonate. So they're going to basically say, right, we're not going to reabsorb the bicarbonate, which is causing our high pH. We're going to let that go in our urine, and instead we're going to reabsorb hydrogen ions, right? In metabolic alkalosis, it's in this case it's a little bit different, right? So we have too much bicarbonate, and again resulting in too high a pH. So in respiratory, we're talking about carbon dioxide levels. In metabolic, we're talking about bicarbonate levels. So when do you lose a lot of bicarbonate? Well, if you lost a lot of acid in your stomach, for example, remember that chloride shift we had talked about, and how the blood will go, there's an alkaline tide in the blood when you're producing lots of stomach acid. So if you've lost a lot of acid, like in vomiting, your body has to replace it. Well, you're going to go metabolic, you're going to go alkaline a little bit. Certain diuretic drugs will also cause metabolic alkalosis, as will certain drugs. So how do you fix that? Well, you slow down breathing. You can hold your breath, right? So basically, by holding your breath, what that ends up happening is you increase your carbon dioxide levels, and that drives the equation to the right. You're going to increase your hydrogen ion levels, which will decrease your pH. All right. So that's it for this section. I really hope that made sense to you. Please let me know if you have any questions, and I will see you after this exam.